Good day, Professor Theo. In this case, I talk about the workshop number 11 and 12. The names of these workshops is BOR, BOR, and ELS. And the 12th workshop is the BHF communication. Okay, first, I will start with the BOR and ELS system. During the session, we worked on the 42 NAP AP, signal generator, the KN53 receiver, and the Garmin. The main goal was to learn how to tune the frequency, verify the stability of the signals, and observe the response of the copied instruments. For the board mode, in the board mode, I set the generator to specify frequency. For example, 180 megahertz, and verified that the CDA bar center rate correctly when the course was on track. Next, and for the ELS, we use two main principal systems. What is the localizer and glide loop? Next, and in the ELS localizer, I worked the signal operates in the VHF band and provides horizontal gates, helping the aircraft stay aligned with the runway, and centerline the runway. In in this case, in the NAP 402, I set the points, the steps, step for a step, where I use the correctly use of the ELS, in this case, a localizer. Next, in the glaze loop, what is the glaze loop? Glaze loop on the other hand operates in the UHF event and provides vertical guidance. The vertical guidance is the three grades, the runaway with the aircraft. Claro, to maintain the correct descent angle, which is normally three degrees. Now, using the NAP 402 generator, I select log fixed mode, adjusted the DDM control, and observed the distribution. What is the deviation? The dots. The dots moving left or right on the instrument, on the CDA, or HSI in the Garmin. Then I switched to glaze loop, fixed mode, adjusted the GSDDM control, and saw how the dots move vertically, representing the aircraft being above or below the idle glide. This experience allowed allowed our pilot during the landing, specifically is in the landing for the pilots. Now, the next workshop is a VHF. In this case, I talking about the modulation and power. What is modulation? Modulation is where the voice, queremos enviarlo y lo modulamos a una cierta frequency. In this case, is the 118 to 137. Where for the power test, I connected the wattmeter between the transmitter and the system load in the power rate. I tested two different frequency. In this case, with with this formula, I select two frequency and For example, my frequency is 120.3 and 125.5. Uh, in this case, in 125, I obtained 19 watts forward and 3 watts reflected with a BSWR of, en this case, se nos dijo que era de 1 o 2. In this case, I 1.46, which indicates good impedance matching and effective power transfer. These dates helped me understand how important it is maintain low reflection values to ensure clear and relief communication. Next, for the modulation test, I used an oscilloscope connected to transmitter output in the interactuate the voice. In the oscilloscope, I saw the voice and the modulation I select on the audio panel, the NAP1 communication 1, process the PTT, push to talk, and spoke through the microphone. The oscilloscope showed a clear AM waveform with the modulation level or the modulation level I in the manual say 70% modulation. In my case is 88, 88%, slightly higher than the nominal 70%. The signal was stable without distortion, confirming the transmitter and the emitter circuit were operating properly. The Borealis and the VHF communication. Through this practice, I strengthened my technical understanding and also learned how to verify equipment operation using real instruments and proceeding similar to those in the actual aircraft. It is all. Thank you.